Hey guys, hope everyone's doing all right. Welcome back to term two. We are continuing on with algebra for the first kind of 4 weeks of this term, combining it with the stuff that we did at the end of last term. What I want to do today is go through the first maths-based task that we're going to start with, which is just called expected skills. So basically, it's a review, a recap of everything that you hopefully might have gotten from the tasks last term. I'm going to go through not every question, but kind of like one of each type. You can skip through if there's a specific question you need. Please don't feel like you have to watch it all. If you are choosing to work through the printed work, the textbook version, basically everything after this lesson will match up basically 1-to-1. So even if you are doing that printed work because you don't want to use the maths-based tasks, you can still use the videos. So for example, the next one's going to be about factorizing. There still is a maths-based task in factorizing, but you could also do it in the printed work if that's what you elected to get. Okie dokes. So I'm going to start by going through some index questions using the index laws. The first one here, you can see this task has 21 questions. So the first one here is to simplify the following expression. There's 2 steps to this. On the top row here, you can see that I've got a power outside of a power, all right? We've got x to the 4 all squared, and then it's all over x to the 5. If you remember BIDMAS or BODMAS, anything like that, if you remember BODMAS, the O stands for order, which means highest power, and index obviously stands for indices. So what we actually need to do is deal with this power before we do any dividing. So hopefully you remember from last term that when we have some power with another power, we need to multiply those powers. So that's like 4 times 2, so it's going to be x to the 8 on top, just leaving x to the 5 on the bottom. Now that it's division, remember what we're doing is we're saying where is the bigger power of x? That's on top. So I'm just going to write the x on top. If there was a number on the bottom, you would write that number. For example, here that number is 1. We don't tend to write 1s in algebra though, because it's kind of unnecessary. So I'm just going to have the x on top. And now I'm saying that there is 8 minus 5 x's. Another way of saying that is that you're cancelling 5 from the 8, which would leave you with x to the power of 3. Okay, so there's 2 rules in that question. Question 2 here is very similar to question 3. I'll go through question 2 because question 3 just uses order of operation, so I'd like you to have a crack at that one. All you need to realize here is that we have whatever this is to the power of 0. Now, anything to the power of 0 is just going to be 1. And then hopefully what you can realize is if that first bracket is all just 1, then that second bracket is also 1. So it just equals 0. Okay. In question 3, you need to remember that we're going to be dividing before we add, and that we have to do our squareds first. In fact, I might just quickly, let's go through that one. So on that first set of brackets, there is an extra little trick, which is why I'm going to go through it. What you'll notice is that the squared is out here. So both parts, the number and the algebra, are going to be squared. So it's actually going to be 4 squared h to the 0, because 0 times 2 is still 0, plus, now I'm going to simplify this second bracket before I do my division bit. So I'm just going to write it out again and go 18 divided by, now this is 3 times g to the 0. It's not all to the power of 0, otherwise it would be in brackets. So it's 3 times 1, because remember anything to the power of 0 is 1, or just 3. Now I'm also going to tidy up that h, because h to the 0 is just 1. Again, I don't need to write that either. And I eventually get left with this as my question. And you could just chuck that in your calculator, or you could just figure it out and go, well, 18 divided by 3 is going to be 6. 4 squared is 16, plus 6, you're going to get 22. When you do these, the numbers might be slightly different, or they might be the same. I'm not too sure. I can't remember what I did. I said these ages ago, but hopefully that helps you get through a few of them. I'm going to go through an expanding. I think it would be best if I chose 5 because it's quite a tricky one. So when you expand, you are multiplying that number out the front by both parts inside. Okay, so I'm going to have to do minus 4t times 4t. Now I've got minus 4 times 4, which is minus 16. And then I've got t times t. Now, it doesn't make sense to write 2t because we've already got a number out the front. So we know it must be t squared. And then for the second part, so that's the first part, the second part, I'm going to have minus 4 times 3. So minus 12t. And that's expanded. When you do it with this question here, the trick is that you're going to have, I may as well just quickly rip through it for you. We're going to have 7 times 8, which is 56. Now, S and T are different letters. So don't write ST8 because we can't actually bring them together. It's S cubed, T to the 5. Done. The second part is 9 times 7, which I think is 63. S cubed, and you're done. You're going to get really unsatisfying big answers. The only trick with 7 here is that you need to expand that one, just like we did here, and then expand this one, just like we did there. And you're going to have some big answer minus whatever big answer you got there. You got to make sure that you subtract that whole right side. So I'll quickly do the second part of that question so you don't get stuck on that. So we're going to have whatever our first answer is, I want to leave that for you, minus, that's going to be 28 UV, minus, what do we get? 14 U squared. Now, what I've done there is I've sent the negative 7u through to both terms. Now, what that means is all I need to do out the front is whatever my answer is here, I'm going to bring all of the like terms together. So I may have another u squared. If so, that can combine with minus 14. And I might have another uv, and that can combine with minus 28 uv. All right, so we're already like a third of the way through. That's pretty good. These ones are going to be some fraction skills. So the thing with adding and subtracting fractions is we can only bring the numerators together, the number, when the size is the same, and that size is the denominator. So if we have two fractions where the denominator is the same, the size is the same, then it's just like saying I've got 2x plus 7x of that size. You can write it over the same denominator. Don't add these 7 plus 7 and get over 14 because the size is what's on the bottom. So we want that to be 7. Then I can just call that 9x over 7 and we're done. Cool. If there was a number that went into both 9 and 7 besides 1, because 1's not going to cancel anything, like maybe 3 goes into 9 and 3 went into 7, which it doesn't, then you could simplify those numbers. Okay, so for 9, you'll notice that our denominators are not the same. I need to make them the same. Lots of ways to think about this. The easiest is usually to say, well, what's a number, the smallest number that 5 and 7 both go into? There's no shortcuts here, it's 35. And you get that by multiplying by each other. So 5 times 7 and 7 times 5. When you multiply the denominator by a number, you need to multiply the top by that same number, otherwise it goes out of scale. So to keep it balanced, we need to multiply the top and bottom by that same number. So keep in mind, the goal here is to get them both over 35 because that's the number they both go into. So you don't really need to write like times 7 or times 5 on the bottom. We're just trying to get them over 35. On top, I need to times by 7 on this side. I'm going to get 21x. I need to times by 5 on the other side. I'm going to get 10x. Now that they're the same size, I can write them over 35. What's important here is I've got a minus. So it means 21